So, hello, my dear friends. Today, I'm going to be teaching you geography. Today is going to be geography. We're going to be dealing on geography. And on this geography topic, we'll be dealing on solstice and equinox. Solstice and equinox. So, as it were, you have to understand that there's something called Earth revolution. Earth revolution. So this Earth revolution happens as a result of it happens as a result of the effect of because of the tilted nature of the Earth. So that's why it happens like that. And we want to be deliberating on it, as it were. So this is geography. This is geography, and I'll be taking you on that particular topic. I'm taking you on that topic now, so you learn about geography. Learn about geography. There's a lot to learn in this concept. So, when you talk of solstice and equinox, you should have in mind that we have like the four phases of the Earth during this time of changes. So we have the autumn, we have this winter, we have the spring, and we have the summer. So these things, as you see it, these are the three things that we are going to be touching today. The four most important areas we are going to be touching today. So we have the Earth rotation, Earth moving around the sun. Earth rotation and Earth revolution. When the Earth is moving around the sun, it is called revolution. And it takes this revolving Earth 365 and one quarter days. 365 and one quarter days to complete the revolution. Now, this 365 and one quarter days is like 365 and 6 hours. So the 6 hours is now added every single year up to like 4 years. So when you have these 4 years now, 6 hours, 6 times 4. 6 times 4 will give us 24 hours. So that 24 hours, which is, you have your 1 quarter days. 1 quarter days is 6 hours. So when you get these 6 hours into 4, you'll now be getting 24 hours. So these 24 hours you have, when you get it in 4 years, in 4 years, you'll be having 1 extra day. So that 1 extra day you have is what is regarded as our leap year. So leap year normally occurs every single 4-year term will have your leap year. So the leap year, as it were, leap year as you know it, is basically when you get 6 hours times 4 accumulations. You get your leap year. So leap year is now going to give us 366 days. So these 366 days, which is a leap year, we have is going to be like the normal thing we were used to. So now we are going to be dealing on the changes occurring during this Earth revolution. Like I told you, revolution. This is the effect of Earth revolution, which is regarded as solstice and equinox. Solstice and equinox. So when do we normally have these things? When does it normally occur? So it happens as a result of Earth revolution. So when there is Earth revolution, this particular sun you see here will be practically overhead in different regions. This sun you see here could actually be overhead at the Arctic Circle or the Antarctic Circle. So normally it used to be overhead in 2 regions. You get the point? So when this sun is overhead, that is when we now have the solstice and equinox. If it is overhead at the equatorial region, that's where you normally have the equinox. If it's overhead at the Arctic or Antarctic Circle, that's where we have the solstice. So, as you can see, when we say that the sun is overhead, because we have this as the earth, this thing as the earth here now. Have this as the earth, and here is the equator. Here is the equatorial region. Here and here is regarded as the Arctic, and this is Antarctic Circle. So here is 0 degrees, here is 23 and half degrees. So when the sun is overhead on the equator, this is when we have the equinox. When it is overhead here, this is where you have the solstice. So if it's overhead here, we have the autumn, we have the either the winter or summer solstice. I will still explain it. If it's overhead here, we have the solstice. So solstice normally occur here and here. But if it happens here, it's called the equinox. So when does this? Why do we normally have this? Why do we normally have these situations? It's as a result of the angle of the Earth tilt. The Earth is tilted at this angle. You can see how I wrote it. How it is written. So because of this tilted angle of the Earth, the way the Earth is positioned, because our Earth, if you draw it accurately, is that the Earth is positioned in this angle like this. So once it is moving, it is moving at an angle. So this movement of the Earth at a particular angle is what we normally have in regards to this equinox and solstice I'm explaining. So we have our autumn, we have our winter, we have our spring, we have our summer. Now, when the sun is practically overhead at the equator, meaning that the sun rays is actively focusing on the equatorial region. What are the countries in this equatorial region? These are some West African countries like Nigeria and some other countries. So when it is focused on this region, we used to have equal day and equal night. When it is overhead at the equator, we used to have equal day and equal night. All over the world, from the northern side to the southern side, we used to have equal days and equal nights, which means 24 hours of day and 24 hours of night. But the moment we move, the sun is no longer overhead at this point. The sun has left the equatorial region and is moving here. It's moving in the northern hemisphere, the Arctic Circle. This is the north. This is the south. This is the west. And this is the east. So when it has left this region, moving in the northern side, it has left the equatorial region, moving in the northern side, and it's not going to focus on the Arctic Circle. It's not going to be overhead on the Arctic Circle. Once it is overhead at the Arctic Circle, we now have a continuous daylight. There will be a continuous daylight whereby regions or countries in this area of the world will have more days, more lights, like they have more hours of day than night. They might have some varies. Some might have like 15 hours, some might have like 14 hours of day, and then the remaining part of the hours will be night. Some used to have 20, but at this region of the equator, the northern hemisphere, the core north, will have what is called 24 hours daylight, no darkness. So they used to call it the day of the midnight sun. And it happens around June 21st, 22nd. That's what it used to happen in the northern hemisphere. So when this thing happens in the northern hemisphere, this particular thing happening in the northern hemisphere, it means that this side of the earth, the southern hemisphere, will experience continuous darkness. Continuous darkness. So this continuous darkness it will be having in the southern hemisphere here automatically means that there is no sun rays being pushed on this region. There is more sun rays here and there is no sun rays here. So, but the moment it starts moving from here to this point, maybe it has reached here. The sun has reached here again. The apparent movement of the sun. It is actually the earth that is moving, not the sun that is moving around the earth. It's not earth that is moving around the sun. So, but this apparent movement is a situation whereby it's a false movement. It appears like the sun is moving, whereas it is not really the sun that is moving around the earth, rather it's earth that is moving around the sun. So once it is at this region now, you now have a situation whereby there will be longer day. There will be 24 hours of daylight here, and there will be 24 hours of darkness in the northern region. Especially Antarctica, this particular continent used to have that alternation of more days or more nights. So, but this point now is where you used to have this continuous daylight, and here will be what? Continuous darkness. So in which part of the year does it happen? I have told you that for this particular equator, when we have equinox, whereby the sun is at the equatorial region, this sun is at the equatorial region. If this is the equatorial region, for instance, this is the equatorial region we are talking about. This is the equatorial region for Earth. This is the equatorial region here. So here is the sun. So once the sun is overhead at this equatorial region, we have equal day, 12 hours. 12 hours. Nke night. This one is night. This one is day. This one is day. This one is night. "12 hours, 12 hours." So once the sun is overhead at this point now, you'll be having equal day and equal night in March 21st, which is called spring. So we have spring equinox happening at March 21st. This thing means that on this day, 21st of March, every year, sometimes can be 22nd or 21st, it means that the whole Earth surface is going to experience equal day and equal night, 12 hours, 12 hours. And in September 23rd, today is 15. So 15, 16, 17, 18, 19, 20, 21, 22, 23. In the next 8 days, we are going to have what is called autumn equinox. This is where we have equal day and equal night all over the globe, everywhere. So, but the moment we left this particular place now and moved to December, which we are approaching, 22nd December, this is when the northern hemisphere, here you see it, this part of the Earth will be experiencing longer night, and here we'll be experiencing longer day. So this region now will have on 22nd December. 22nd December will be more light on the southern hemisphere, whereas in the 22nd December, this side will be what? Darkness. So that's regarded as what? Winter. So it varies in some countries. Some countries used to have more number of hours in a day, like 15, like I said, 14, 17, 18, depending. But in the core north, that is where we have continuous darkness for 22nd December. So when it is moving from there, it moves here and reach here, which is the what? The spring. We have that equal day and equal night. It moves from this point and reach to June 22nd. I mean June 21st or thereabout. So this is the Earth, and in this part of the Earth, which is called spring, we will now have what? Here will now be full of darkness. And here will be what? Light. Continuously. And moves here is completed. So these are the things that happens as a result of what? Earth revolution. So I know you have learned something today. A minute. I know you have learned something today. You have learned a lot today as regards to the things that has to do with the Earth surface. So let me know how this live video has actually impacted you, what you have learned from the video, so we can move to the next agenda of what we are trying to explain. So we have it as it were. Now this is effect of Earth revolution. The effect of Earth revolution. So this effect of Earth revolution, I've explained to you. One of them is this equinox and the solstice. So, and the Earth is usually overhead at the Tropic of Cancer and Tropic of Capricorn. This is the Tropic of Cancer, and this is Tropic of Capricorn. This is Tropic of Cancer, and this one is Tropic of Capricorn. That's when it is normally overhead. Where it is normally overhead. So, and this particular effect of the Earth revolution causes several seasons to occur, especially in temperate countries. They used to have like 4 seasons, and these seasons they used to have are winter, autumn, and summer and spring. So that is what they used to have in their region. So that is it. That is it, by the way, for the thing we have to explain as regards to this aspect of our lecture today. So, what again are we going to be dealing on now? I'm going to be dealing on another important aspect, which is latitude and longitude. Latitude and longitude. We're going to be dealing on latitude and longitude. Latitude and longitude. We're going to be dealing on latitude and longitude. Latitude and longitude. We're going to be dealing on it. Latitude and longitude. So when you hear the word latitude, what comes to your mind? Latitude is actually an angular distance of a point on Earth's surface measured in degrees from center of the Earth to the north or south of the equator. So if here is our Earth's surface and this is the equatorial region, 0 degrees. So it means that latitude is simply an angular distance of a point on the Earth's surface that is measured in degrees. That is measured in what? In degrees. From the center of the Earth, which is equator, to the north or south of the equator. From the center of the Earth here to the north or south of the equator. So here is lines of latitude running from the center of the Earth, north or south of the equatorial region. So that is the simple definition of the meaning latitude. Latitude as it were. So that is it. And we have important latitudinal lines. One of the important latitudinal lines we have is the Arctic Circle. This is the Arctic Circle, which is 66.5 degrees north. This is the Arctic Circle, and this is the Tropic of Cancer. Tropic of Cancer. Tropic of Cancer, which is 23.5 degrees north. And here is the equatorial region. Equator. And here we have the Tropic of Capricorn. Capricorn, which is 23.5 degrees south. And here is what? Antarctic Circle, which is 66.5 degrees south. Here is our South Pole. South Pole, which is 90 degrees south. And here is our North Pole, which is 90 degrees north. So these are the most important lines of latitude on the Earth's surface. The most important lines of latitude on the Earth's surface. On the Earth's surface. On the Earth's surface. So that is it. What do we use these lines of latitude to do? What are the uses? What do we use these things to do? The lines of latitude, in conjunction with that of longitude, they are used to determine the exact location of places. Exact location of places. Exact location of places. That's what they are used to do. Exact location of places. And they also used to calculate distance between two places. They used to calculate distance between two places. So that's what we use it to do. The most important to use it to do to calculate distance of two most important places on the Earth's surface. So now, how do we calculate lines of distance of using? How do you go about calculating distance between two places using the lines of latitude? How to calculate distance using lines of latitude. How do you calculate it? Distance using lines of latitude. The procedure for calculating it is that we have to locate the two places involved. Locate the two places involved. When you locate the two places involved, you will find a difference between the two places involved. When you do that, you now multiply the latitude difference by 101 kilometers. So for instance, I want to know the distance between two places. What do? I want to know the distance between the equator and Egypt. At 30 degrees north latitude. How do I get it? How can I get this distance? How I do is that the two places involved, the two places which you have are latitude what? 0 degrees and 30 degrees north. Now, the second this thing you need to do for you to get this. Once you have found it, you find the differences, latitude difference. So what is the latitude difference of these two regions? The latitude difference is 0 degree plus 30 degrees, which is 30 degrees. That is the latitude difference. Somebody might be interested to know, why do we use plus for the latitude difference? The reason is because when you have north, you subtract. When you have north-south, you add. Whether you have equator, north or south, you have to add or you subtract. So what you do is this. When you have two places and they are bearing north, two places, and these two places has north, like north latitude and another north latitude, what you do here is you subtract. You subtract. If it is south, what do? You also subtract. But if it is north, south, what you do is you add. You add to it. So that is how you do it. That is how you're able to get it. But if it is equator, either you add or you subtract, you still get the same thing in it. So that is the thing we have. As a matter of fact, we have it here. So since we have gotten the difference, the next thing you will do is make an assumption. Since 1 degree is equal to 1,001 kilometers, 111 kilometers. Now, 30 degrees should give us what? When you cross multiply, you're having 30 times 1, which is going to give you 3,330 kilometers. So that is what it meant to have a latitude like this calculation I have done now. So ask your question in the comments. Ask your question. Let me address it. So this is how you can get your latitude. What if you have another one? Another one like this. We are still on latitude actually. We are still on latitude. Distance between South Africa, which is on latitude of 30 degrees south, and Spain. Let me rewrite this. I think it's crashing on this thing. You have distance between South Africa, which is 30 degrees south, Africa, and then Spain. maybe Spain at 40 degrees north. How do you be able to get the distance? Simply put, the two places involved are this and this. They are 30 and 40. So have 70 degrees because they have north and south. So 30 degrees plus 40 degrees, which is 70 degrees. So since 1 degree is equal to 1 kilometers, 70 degrees is what? You do cross multiply. 70 times 1 is going to give you 7,770 kilometers is what you are going to get in this situation. So that is it, by the way, for longitude. I think we're going to be stopping here for today. Maybe next time we'll see how it goes in our next video. Thank you for listening. God bless.